Hello everyone. So today we are going to start the most important topic of network analysis, that is transient analysis. Okay. So even if you consider the interviews, this is the first topic they ask. This is the most important topic. Okay. From basic electrical science or network analysis, whatever you call it, this is the most important topic, and students find it sometimes a bit tough. Okay. So we will start from very beginning. Even if you know the basics, just watch through the video. You will get to know a lot of new things. Okay, so we will start right from the beginning and we'll take you to very advanced level. It will be a much different analysis. Okay, we will deal it in much different way. Okay, so let's just start. So let's just assume you have a system. What is a system? Just consider it as a network. Okay, you are applying some voltage input, you will get some output. So just consider this system as a network. You are applying some voltage input. I am calling that input as xt. For now I am calling that input as xt. So this is my input. Okay, I will have some output. Okay, I am applying some input to the system. I will have some output. I am calling that output as yt. So yt generally have two responses. Okay, one is the transient response and the second is the steady state response. Okay, you generally have two responses, transient and the second is steady state. Okay, now you will say we have seen a lot of circuits beforehand, but we never saw two responses. We just saw a single value, right? I am applying a 5-volt input to a resistor divider RR, I will get 2.5. So that's just a constant value. Yeah, so there is no transient, there is only steady state value. You just applied 5, you got 2.5, that's it. But when there is a time domain signal here, and when there is a storing element connected, you will get these responses, transient and steady state. We will get to that slowly. Okay, so let's just understand it with a analogy. Okay, so let's just assume this is a slope. Okay, and there is a ball here, and you give it a force. Okay, you give it a force. If you give it a force, what will happen? This ball will travel down like this, right? It will keep on traveling down like this, right? Right? At some point of time, it will be stable. It will just not move, right? So this was your point of action, right? This was your point of action. From here you gave a force, and then the ball is moving, and at some time it is stable. So this much of time, no, this much of time, this time is called as transient. Okay, from here to here, this time is transient. So in this state you haven't reached the steady state, you are going to a particular state, and after that it is stabilized. So from here to here you call this time as, from here to till the end. Okay, you call this time as steady state. Okay, this is steady state, this is steady state. So did you understand? I just gave it a force. Okay, then it is just traveling. It is not giving a steady state value, it is not getting stabilized at a certain point, so it is moving currently. So this time is called transient time, and when there is a steady state, that time is called, that position is called steady state. Okay, so we will see examples. Okay, so what is transient? Transient is the time between the point of action and steady state. Okay, point of action and steady state, we will see by the examples, you will understand more. Okay, so what is actually steady state? Steady state is the, what is actually steady state? So we have two responses, transient and steady state. So what is steady state? When t is equals to infinity, in yt, when t is equals to infinity, that we call steady state. Okay, so you can write y infinity. Okay, so this is what we call steady state, because we don't really know when we will reach the steady state, right? We don't really know, like at what time we will reach the steady state. So for reaching the steady state, we put t equals to infinity. So that's what we call steady state. So now there is a question, by question you will understand more. Okay, so there is an equation given of yt, You need to find which one is transient and which one is steady state part. Okay, let's just take first equation. E yt is 5 into 1 plus e to the power minus t. Okay, I can write 5 plus e to the power minus t. What is steady state? Steady state. Steady state is y infinity. So simply put, t tends to infinity in yt. So 5 plus 5 e to the power minus infinity. Now what is the value of e to the power minus infinity? Let's just understand it with the simple thing. Like this thing you should know. What is that? What is the value of e to the power 0? E to the power 0 is always 1. E to the power minus 0, it is the same thing, it is always 1. What is the value of e to the power infinity? That is infinite. E to the power e is 2.7, around 2.7. Infinite, it will go till infinity. Okay. And what is e to the power minus infinity? What is e to the power minus infinity? It is 1 by e to the power infinity. That means it is 0. 1 by e to the power infinity. What is e to the power infinity? It is infinity. 1 by infinity is 0. Okay. So e to the power minus infinity is 0. Okay. So what do you get? Yeah. So what do you get? Y of infinity is 5. Okay. So this is the steady state value. Steady state value. Now what is yt? Yt has two parts, y transient t and y steady state t. What is yt? 5 plus 5 e to the power minus t. So there will have some transient part and steady state part. What is the steady state part? That is 5. So what is the transient part? That is 5 e to the power minus t. Okay. So we have two parts. One is the transient. This is the transient part, right? And this is the steady state part, right? So there are two parts. This is the steady state. This is the transient part. Now we can see by the graph as well. You can draw the graph of 5, right? There are two portions. One is 5. One is 5 e to the power minus t, right? This plus this. Is equals to your final. So let me tell you. What is the graph of y steady state? 5. 5 is a constant value, right? So it is simply this 5. Now what is y transient t? Y transient t. At t equals to 0, you will have value 5. At t equals to 0, you will have value 5. At t equals to infinity, you will have value 0. Right? So from 0 to it goes to infinity. Okay. Actually, in this question, we are only talking about for time greater than t equals to 0. Okay. We can also talk about time less than t equals to 0, but here we are for present time we are talking about time t greater than 0 only. Okay. So yeah. So just making the graph of time t equals to 0 only. Okay. So from 5 to it goes to 0 because at t equals to infinity. So you can see that this thing is decaying. The transient is decaying. At steady state only this will be left. So if you just add them up, what you will get? If you add them up, you will get your yt, right? If you add them up, you will get your yt, right? So you will get your yt. At t equals to 0, you will have 5 plus 5, 10, right? And at t equals to infinity, you will have just 5. So from 10 it will start and will go down to 5, right? So from 10 it starts and goes down to 5. So at steady state, we are having a constant value that is 5 volt. And from here also you can see at steady state you will have 5 volt only. Are you getting my point? What is the actual meaning of transient and what is the actual meaning of steady state? the transient will die out. Okay, it is starting from 5, but eventually it is dying out. So the transient will die out. This will always die out, but this will remain always there. Okay, at steady state you will only see 5. Rest of the part will die out. Okay. Now let's just take the second example, B option. Yt equals to 5 e to the power minus t. So yt equals to 5 e to the power minus t. What do you think? What is y steady state here? Y steady state, that is y of infinity, that means 5 e to the power minus infinity, that means 0. So y steady state is 0. So what is your y transient? This is the complete part, 5 e to the power minus t. So for this function, for yt equals to 5 e to the power minus t, the steady state value is 0. So how will the graph look like for yt? It will start from 5 volt or anything, and it will go down like this to 0. Okay, starting from 5 and goes down to 0. You can make it in a better way. Starting from 5 and goes down to 0. Okay, so eventually the whole transient is dying out. If the whole transient dies out, there is no steady state value, so final value we will get as 0 only. Okay, so the whole transient is dying out here. Now the third option, that is, I guess we can draw the third one here as well. The third one, 5 yt is 5 1 minus e to the power minus t. Okay, so I can write it as 5 into 5 e to the power minus t. So basically your y steady state is 5 only, and y transient is minus 5 e to the power minus t, right? I should have written in a better way, y transient t, that is minus 5 e to the power minus t. Okay, so how it will look like? So this is some 5 volt steady state value, 5 volt plus some transient, part, right? So this two graphs we are adding up simply. Okay, so for this part, at t equals to 0, what is the value? At t equals to 0, it is minus 5, and at t equals to infinity, what is the value? It is 0, right? So this part is constant and this part is dying out, right? That's why this part is transient and this part is steady state, right? And what is the final graph of yt? A final graph of yt, from you can simply add them up. So at t equals to 0, what you are having? At t equals to 0, you are having 0. And at t equals to infinity, what will happen? This part will die out, only 5 volt will remain. So from 0 to it will go to 5. 0 to it will go to 5 volt. Now why the trajectory is like this? Okay, the trajectory is like this. Why is that? We will see that in video. Okay, we will see in the further part of the video. Why is it not like this? Why is it like this only? Okay, we will see all that. Now first we need to see the concept of time. You will get to see a lot of things, a lot of time, this concept. Okay, so like a lot of times you will see this concept. So you will see that the switch is getting closed at 0, the switch is getting opened at t equals to 0. So what does that mean? What is the meaning of t equals to 0? What is the meaning of t equals to infinity? What is the meaning of t equals to 0 plus? All these we will learn. Okay, so what is t equals to 0? Like, it is simply a time. Okay, they can give any time here. The switch is getting closed at t equals to 1. So what does that mean? Before t equals to 1, the switch was open. Okay, so this is like this, t equals to 0. What is t equals to 0 plus? So let's just assume I am closing the switch as t equals to 0. So just the moment I am closing the switch, at that moment I am asking you some output or anything. So the moment at the moment when I close the switch, just the next moment is called t 0 plus. Okay, so this is t equals to 0. This is the time. Okay, so this is very next moment of t equals to 0 0. Okay, and what is t equals to 0 minus? Movement before t equals to 0. Okay, just 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 before. Okay, t equals to 0, just next moment is t equals to 0 plus, and just before moment is t equals to 0 minus. Same with this is t equals to 1. What is 1 plus? The very next moment. Okay, now what is t equals to infinity? What is t equals to infinity? This is steady state. Steady state steady state after the operation of switch. After the final operation of switch. What do we mean by that? Final operation of switch. And this is also a steady state. Steady state before any operation of switch. Now what do we mean by that? I'm saying that I'm closing the switch at t equals to 0. So before t equals to 0, the switch was open, right? I'm saying that at a particular time I am closing the switch. So before that time the switch was open, right? So there was a lot of time before that. Now t equals to 0 is not a particular time. Like, it's not that it's being 12 o'clock or nothing like that. You are just giving up any particular time as t equals to 0. You are calling any particular time at t equals to 0. So before that as well, there can be something happening in the circuit, no? Like before t equals to 0. So that thing is happening before t equals to 0. So this much of time span is from here to, how I should show it. Just a second. So this much of time, this much of time, this much of time is t less than 0. Okay, this much of time is t less than 0, and the time ahead of it, this time is t greater than 0. Okay, this time is t greater than 0. So for now you can just consider that when there is no operation of the switch, at that time the steady state we are having, that is called t equals to minus infinity. And when we have the final operation of the switch, like we have made the final circuit, so when we get the steady state, at that time we call t equals to infinity. Okay, so when there is no operation of the switch, that time is known as t equals to minus infinity, and when there is operation of the switch, when we reach the steady state, it is called t equals to infinity. We will see in the question, you will get to know everything. Okay, but we just need to know how the switching sign look like. You need to understand the switching operation. So if the sign is made something like this, okay, in most of the questions they write what does it mean, but if it is not written, so you have to understand by your own. So what does that mean? That means that your switch is closed at t equals to 0. Switch is closed at t equals to 0, or the switch was open before t equals to 0, right? That means, like, for t greater than 0, this will be the condition. That means short circuit. And for t less than 0, this will be the condition. That means open circuit. Are you getting my point? Switch is closed, that means short circuit. Switch is open, that means open circuited. right? Now if they are making sign like this, that means before the switch was closed at t equals to, if they are making sign like this, I'm talking about this, if they are making sign like this, that means the switch was closed at t equals to minus infinity. Before it was closed, but now they are opening it. That means after t equals to 0, the switch will be open. Are you getting this point? That means switch is opened at t equals to 0. That means switch was closed before t equals to 0. So what does this final mean? That means for t greater than 0, it will be open circuited. Just you just need to understand this point, nothing else. For t greater than 0, it will be open circuited because at t equals to 0, we are opening it. And for t less than 0, what it was? It was short circuited, right? Because you can see the sign. They are opening it at t equals to 0. So before that, it was shorted, right? So this is the final meaning. Okay. So I hope you have understood the concept of time. Gradually, you will understand that with the examples and with the concept that we will learn. Okay. So just see this example. There is a battery. Okay. A simple example. We are closing the switch at t equals to 0. Now they are asking the switch is closed at t equals to 0. You have to find the V0 value at t equals to 0 minus at t equals to minus 1 plus minus 1 plus. Okay. What is minus 1 plus? This is minus 1 plus. Minus 1 plus. These are seconds. Okay. They are talking about seconds. T equals to 0 minus second, 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 and second. Okay. So first thing, t equals to 0 minus second. So it is before t equals to 0, right? First is t equals to 0 minus. So what is the axis? This is the axis. This time is t equals to 0. This time is t equals to 0 plus, and this time is t equals to 0 minus. Switch is closed at t equals to 0, right? Switch is closed at t equals to 0. So how would the circuit look like before t equals to 0? Circuit condition before t equals to 0 or t less than 0. So what is the circuit condition before t equals to 0? The switch is open, right? The switch was open. The switch is closed at t equals to 0. So before that it was open. So there was no connection with 10-volt battery. So the condition was something like this. This is a 10-volt battery and we have an open circuit here. Then we have a 5 ohm. Then we have 5 ohm. And then this. There can be a common ground, right? So this is the condition, right? Before t equals to 0. That means for t less than 0. For t less than 0, this is the condition. That means there is no close path, right? That means the current is 0. That means the value of V0 is 0. Now if they are asking for t equals to 0 minus, even if they are asking for t equals to 1 minus, sorry, minus 1 minus, that means this time minus 1 minus 1 plus, even if they are asking for minus 1 minus, so for every time you will have V0 equals to 0 volt only. So for t less than 0, always your V0 will be equals to 0 volt. Because how will your circuit look like at t equals to minus 1? T equals to minus 1, how will your circuit look like? It will look something like this only. So your V0 eventually is going to 0 volt only, right? If there was some storing element, the story could be different. Okay, but there is no storing element. There are simple resistor. What are the storing element? Capacitor and inductors. I have told you before, right? So if there was some capacitor or inductor, the story would be different. And this is what transient analysis is. But in this question, what is happening? Always you are getting 0 volt. So there is no transient. There is steady state only. So V0 is always 0 volt, right? So for second answer as well, for t minus 1 plus I asked, right? For t equals to minus 1 plus. So your V0 is 0 volt only, right? And third, what is third? Third is asking t equals to 2 plus, right? Third is t equals to 2 plus. So what is happening? For t greater than 0, switch is closed, right? For t greater than 0, what is happening? The switch is closed. So how will the circuit look like? Like this is your 0, this is your 0 plus, and this is your 0 minus. So now how will the circuit look like? 10 volt battery shorted to 5 ohm and 5 ohm. Right? This is 5 ohm, this is 5 ohm. Now they are asking V naught. Your V naught will be, for t greater than 0, it will always be 5 volt, right? So for t greater than 0, the switch will always be closed, and at the moment you close the switch, at the certain time you will get V naught equals to 5 volt. So if they would have asked what is the value of V naught equals to, V naught at t equals to 0 plus, V naught at t equals to 2 plus, V naught at t equals to 10 plus at any time, or V naught equals to at 10 minus as well, t equals to 10 minus as well, or 2 minus as well, for time t greater than 0, it will always be 5 volt, right? In D they are asking at time t equals to infinity, right? Plus infinity. So what will be the value? Tell me. So V naught at t equals to infinity will be 5 volt only, right? So how will you make the graph of V naught? How will you make the graph of V naught? V naught was 0 for t less than 0, right? V naught was 0 for t less than 0, and suddenly it goes to 5 volt. It was 0 volt, and then suddenly it goes to 5 volt. At t equals to 0, when the switch is closed, it goes to 5 volt, right? Are you getting this point? I hope you are understanding this point, right? So I hope you have understood the concept of time now. What do you mean by t equals to 0, t equals to 0 plus, t equals to 1, t equals to 1 plus? By, like, this was not an example of transient, because here there is always steady state, because there are resistors. In the resistor, it won't take time to reach any voltage, but when there is a capacitor, it will take time. The capacitor will take time to reach to a certain voltage, but in case of resistor, we immediately get to a certain voltage. Okay, so we will see those examples of capacitor, but this example I took only to give you the concept of time. What do we actually mean by the concept of time? So I hope you have understood it here, right? The switch is getting closed, we are getting a certain value. When it is opening, we are getting a certain value, right? So let's just see the concept of time constant. We will be using this term again and again. So just forget what is time constant, anything. You just need to make the graph of these two functions. Okay, yt is equals to v naught e to the power minus t upon tau, and yt equals to v naught 1 minus e to the power minus t upon tau. So you need to make graph of these two. Okay, so first we will start from this one, y naught equals to e to the power minus t upon tau. Okay, so what will be the value of what will be the value at t equals to 0? So y of 0, that will be y naught e to the power minus 0, that will be y naught. So this is 100% of y naught, right? 100% of y naught, right? Now at t equals to tau, I will put at t equals to tau. Okay, so it will become y naught e to the power minus 1. So if you solve it, it will become 0.363 or 37 you can write. Okay, 37 you can write, 0.37 y naught. So that is 37% of y naught, right? nearly 30% of 37% of y naught, right? 37%. If you put 2 tau, it will become, okay, so it would become y naught e to the power minus 2. You can solve it in the calculator, right? Y naught e to the power minus 2. So what is the value of y naught e to the power minus 2? That is 0.13 y naught. That is 13% of y naught. What will happen at 3 tau? It will become y naught 3 tau by 3. So it will be nearly 0.05 y naught. That means it is 5% of y naught. Are you seeing this point? This is a complete transient response, right? There is no steady state. We will start from y naught and it will decay down to 0. We will start from y naught and it will decay down to 0. So as the time is increasing, for 0 tau, 2 tau, 3 tau, 4 tau, as the time is increasing, the value is getting down, right? For y equals to 4 tau, what will happen? It will become y naught e to the power minus 4. So it will be nearly 0.02, I guess. Yeah, 2% of y naught. Only 2% of y naught is left. And at y equals to 5 tau, what will happen? It will become 0.006 y naught. That means it is 0.6% of y naught. What do you understand here? In this part, you are nearing the steady state. Nearing the steady state. Right? What is steady state? Steady state is 0 voltage. Let's just assume your y naught is 100. So at 3 tau, what you will have? 5% of y naught. 5. At 4 tau, what you will have? 2% of y naught. 2. At 5 tau, what you will have? 0.6% of y naught. That means 0.6. So like now it depends on the person who is asking you the question. So nearing steady state means it is called settling time. Okay. Now if someone is asking you what is settling time, so you can actually say it is 3 tau, someone will say it is 4 tau, and someone will say it is 5 tau. Okay, what is tau, that we will see, but I'm talking about settling time now. So someone can say 3 tau, someone can say 4 tau, so someone can say 5 tau. So who is correct? Everyone is correct, but the person who is asking the question, he has to tell you like how much error he wants. Like he says that I want 95%, 5% of error. That means you need to go to 0 voltage. Okay, you need to go to 0 because the final value will be 0, but 95% error can be there. That means your value can be 5% of y naught. Are you getting it? Sorry, yeah, it should be 5% of y naught. If he is saying I want 95% accuracy and 5% of error can be there, so here 5% of error is there. Here if we want 98% of accuracy, that means it will be 2 that it will be 4 tau. Now if he wants 99.4% of accuracy, then that it means it will be 5 tau. If he wants 99.8% of accuracy, so it will be greater than 5 tau, right? Because you want only an error of 0.2%. Here you are having error of 0.6%, but someone wants an accuracy of 99.8%. That means he only can have 0.2% of error, right? So the time will be greater than 5 tau. So are you understanding this point? So someone says that 3 tau is the steady state, someone says 4 tau is the steady state, someone says 5 tau is the steady state. All are steady state, but the difference is of the error. Okay, the difference is of the error. You need to go to 0 volt, but you are slowly going to 0 volt. So how your graph is going to look like? So you are starting from y naught at t equals to tau. What you are having? At t equals to tau, you are having 0.37 y naught, right? It is 0. I should write it a bit ahead. 0.37 y naught. At t equals to 2 tau, what you are having? 2 tau, someone calls this tau. Actually, the real name is tau only, but I call it tau. Okay. So at 2 tau, what you are having? 0.13 y naught. 0.13 y naught. At 3 tau, what you are having? At 3 tau, you are having 0.05 y naught. Actually, there should be unit gap, like there should be a constant gap between these two, but since like the screen is small, I can't really make much bigger graph, right? Actually, between toe, 2 toe, 3 toe, there should be uniform gap, right? There should be uniform gap, but I can't really make the uniform gap here. And you can just assume the graph would look something like this: 0.05 y naught, then 0.02 y naught, 0.02 y naught, and eventually you will have 0.006 y naught. So like these times are settling times, settling time. And what is settling time? That means you are near reaching the steady state. Okay. And this time is called time constant. Okay. This time is called time constant. Okay. So what is the definition of time constant? So multiple definition you will see. One definition you see as a 36.8% and one definition you see as 63% something. So never look at this definition. This is the only definition of time constant. Okay. So let me explain it to you. Yeah, so what is time constant? Time constant of a circuit is the time required for the exponential transient response to decay to a factor of 1 by e or 36.8% of its initial value. What was its initial value? Y naught. When it is going down to 36.8, or you can say 37% of its initial value. So what is the 37% of its initial value? That is 0.371. So how much time it is taking? 2. Okay. So like in this graph, what is the transient part? The complete graph is the transient part, right? The complete graph is itself a transient part. The complete function, right? So this is the complete function that is complete transient part, right? So what we are saying, time constant of a circuit is the time required for exponential transient response to decay to a factor of 1 by e or 36.8% of its initial value. Okay. So from y naught it is decaying down to 36.8 or 37% of its initial value. Okay. Now those who have already studied this topic, they will think that there is one more definition as 63%. Like someone says that they are reaching the 63% of some final value or anything like that. So let me explain that thing. Okay. So we will see that thing in this example. Okay. So tell me, there are two parts, right? There are two parts. This is the steady state part. And this is the transient part. Right? So I will make both of the graph now. This is my steady state. What is my steady state? That is simply y naught. Plus I will add up the transient part. In the transient part, the negative sign will be included as well, right? Because we are always writing steady state plus transient. So if there is plus, so negative sign will also be included. So this is the transient part. So at t equals to 0, it will start from minus y naught and will decay down to 0. Right? Now tell me, okay, first let's just make the graph of yt, then we will talk. So let's just make the graph of yt, complete yt. So at t equals to 0, you will have at t equals to 0 y naught minus y naught, it will be 0. At t equals to infinity, you will have y naught. From here to, you will go to y naught. From 0 to, you will go to y naught. From 0 to, you will go to y naught. Right? Now tell me, what is the value of, what is y transient? Here your y transient part is minus y naught e to the power minus t upon 2. So what is the value of transient part at t equals to 2? It will be minus y naught e to the power minus 1. That means 0.37 of y naught. 30, what is the, let's just call this as 2. Okay, this time as 2. 37% of its initial value, right? This is the 37% of its initial value, right? But only for this is the transient part, right? So this is what I told you in the definition itself. Time constant of a circuit is the time required for the exponential transient response. This is the most important part. For the exponential transient response to decay to a factor of 36.8%. Like someone will say at t equals to tau, you are reaching the value of, here at t equals to tau, what value you will reach at t equals to tau? Let's just assume this is my t equals to tau. Okay, so in this graph at t equals to tau, you are reaching a value of, so at t equals to tau, y, what is yt? Yt is y naught minus e to the power minus t upon tau. So at t equals to tau, you will have y naught minus, it will be 0.37 y naught. So it will be nearly 0.3663 y naught. So you can't really say that you will reach the 63% of your final value. You can't really make the definition like this, right? There is only one definition, that your transient response will reach the 37% of its initial value, not the maximum value. What is the maximum value of this transient response? What is the maximum value of this transient response? 0. And what is the minimum value? Minus y naught. So you can't say the minimum value. You will say the transient part will reach 37% of its initial value. 37% of its initial value. It can be y naught, it can be minus y naught, it can be anything. It needs not to be the minimum or maximum. It just 37% of its initial value, but only the transient part. In this question, we have two parts, steady state and transient. But when we are defining the time constant, we will only care about the transient part. Okay? In the previous example, what was happening actually? There was no steady state part in this problem, right? There was only the transient part. The steady state part was 0 itself. So this was yt, this was also y transient t. So here your yt was equals to y transient t, and your y steady state t was, y steady state was 0, right? So that's why it was like, I have seen even some student or some professors writing the definition as like decay to 37% and increase to 63%. But that's not the actual definition of time constant. The actual definition says that the exponential transient response will decay down to 36.8% of its initial value. That's it. Okay. So here as well, it is the same thing is happening. It is going to the 63% of its final value, but the transient response is getting decayed to 37% of its initial value. Are you getting my point now? I hope you have understood the point. When we are defining the time constant, you only need to think about the transient response, not the steady state. Just subtract the steady state part, only the transient response you will see. Initial value you will see, and the 37% of its initial value you will see. That's it. Okay, well and good. So like, you don't need to do this much of analysis if they ask you what is the transient response. sorry, what is the time constant of the circuit. So how you will find it? So any exponential transient response can be written in the form of y naught into e to the power minus t upon tau, where tau is your time constant. So tell me, what is the time constant of this circuit? Forget the steady state part. This is the steady state part. Forget it. This is the transient part. E to the power minus t upon tau. This is the time constant. 5 seconds. Tell me what is the time constant of this circuit? Of this, not circuit, of this equation you can say. Y naught e to the power minus t upon tau. T upon tau. But it is written 4. So it would be minus t upon 1 by 4. So minus t upon 1 by 4 you will write minus 4t. Right? The time constant is 4 seconds. Tell me the time constant for this. So I guess I should not 4 seconds actually. It will be 1 by 4. Sorry. It will be 1 by 4. So it will be 0.25 second. Forget about the DC part or steady state part. Forget about the steady state part. Only this e to the power minus t upon tau. Minus t upon tau. Upon tau. So 1 upon 0.125. That means 8 seconds. Right? Are you understanding this point? Let's just assume it is written minus 8t. So what will be the time constant? 1 by 8. Not 8. 8 is not the final answer. 1 by 8 is the final answer. T upon tau. So the lower one, 1 by 8. Okay? I hope you are getting the point. Okay? Now let's just put one more question. Yt equals to 6 e to the power t by 4. Tell me what is the time constant? Tell me what is the time constant? Minus 4. Minus 4 seconds. No. Will always be a positive value. Okay? Positive value. So this is not even a transient response actually. Why so? Because it is not dying out. What is the graph of Yt? What is the graph of Yt? Tell me. Graph of Yt. At t equals to 0, it is 6. At t equals to infinity, e to the power infinity is infinity. So it is going to infinite. Oh, sorry. It won't go like this actually, because it is not stabilized. It will go like this. It is going to infinity. This is an unstable system. Unstable system. There is no transient, because transient eventually dies out. Transient eventually dies out. At t equals to infinity, the value of transient is 0. But here the transient is not dying out. So there is no transient. That means time constant is not defined. Okay? Time constant is not defined. So you just can't close your eyes and tell the time constant. You first need to see if there is a transient response or not. Because if it is dying out or not. Time constant is basically comments on the speed of the circuit. Okay? If the time constant is more, what does that mean? It will take more time for the transient to die out. Did you understand this point? Okay, I will write it. First, I will write that time constant is not defined. Just let me add a page. Because this is a very important term, like people don't know much about this term. So I'm just discussing. I will write down a note, that is time constant defines the speed of the circuit. Defines the speed of the system, we will write here. Defines the speed of the system. Now, more time constant. If time constant is more, what does that mean? That means transient will die out slowly. Transient will die out slowly. Will die out slowly. How? Just see this graph. If toe was a bit ahead, if toe was here, like it will take time to decay down, right? Let's just assume my toe is 1 second. That means I am reaching 37% of my final value in 1 second only. If my toe is 2 seconds, that means I am reaching the 37% of my initial value. Sorry, 37% of my initial value in 2 seconds. Here I said final value, I guess. So 1 second, toe is 1 second. That means reaching the uh, reaching the sorry reaching the initial value of 37% of initial value in 1 second, and t equals to tau equals to 2 seconds means reaching the 37% of initial value in 2 seconds, right? And if my tau is 2 seconds, that means my settling time would be 10 seconds. If my tau is 1 second, that means my settling time would be 5 seconds. So that means my transient will die out slowly. That means we will have steady state. Steady state will be reached slowly. Steady state will be reached slowly. More time constant, that means transient will take time to, transient will die out very slowly. That means steady state will be reached very slowly. That means the system response is slow. System response is slow. So more time constant means system is slow, and less time constant means transient will die out fastly. Transient will die out fastly. Steady state will be reached fastly. Steady state will be reached fastly. That means system response will be fast. Okay. So time constant actually defines the speed of the system. Okay. So if your time constant is low, that means your system is fast. Time constant low means your steady state will be reached fastly. That means your system response will be fast. And if your time constant is more, that means your system response is slow. So if more time constant means the system will get down, will be slow. So you don't want your system to respond slowly. You would want an immediate result, right? You would want an immediate result. So you would want your time constant to be as low as possible. Can you tell me what is the time constant of this circuit that we already discussed? This circuit. Tell me what is the time constant of this circuit? Think about it and tell me. What is the time constant of this circuit? Comment it down right now. Like if you are watching it live or anything, just you can comment it down. What is the time constant of the circuit? 0 second. Why so? There is no transient actually. There is only a steady state value. Or you can say, what is Yt? Yt is 5 volt. So you can write y e to the power minus t upon tau. Like we can't really comment it like this. No, we can't really comment it like this. Like we can't put it, t equals to 0 here, or if we put tau equals to 0 here, so it would become infinity. So it would go down to 0. So yeah, you can write it like this. You can write like this. You can write 5 plus 5 e to the power minus t upon tau, and value of tau is 0. So if value of tau is 0, it will be e to the power minus infinity. So that will go down to 0. So it is actually Yt equals to 5 volt only. So like there is no transient part. Immediately it is settling to its final value, right? Immediately it is, just as you close the switch, it is settled to its final value. Just as you close the switch, it is settled to its final value. So it is taking no time to reach the final value. So the time constant is 0. So as much time it takes, if it is taking 5 seconds, that means your time constant will be will be based on 5 seconds. Like if it is taking 10 seconds, Like one circuit is taking 5 seconds to reach the final value and one circuit is taking 10 seconds to reach the final value. So which circuit will have more time constant? This circuit will have more time constant, right? Because this is taking much more time, right? So I can take an example. Okay, this we will see in next video. I can add up a page. I can take an example. I will write down the question. So this is the question. Okay, output response of 3 circuit is drawn. Tell which circuit has the maximum or minimum time constant. So tell me minimum time constant and maximum time constant. So which circuit is taking more time to reach the steady state value? Which circuit is taking more time? Circuit 3. That means it has the maximum time constant, right? Because it is taking more time to reach the final value. So it has maximum time constant means this circuit is having, and minimum time constant circuit 1, because it is taking very less time to reach the final value. So it has very less time constant. Okay, so faster the response, lesser the time constant. Faster response, lesser time constant. Okay, so I hope the concept of time constant is clear to you all. So we have studied about time constant in this video. We have studied about the transient response. We have studied about the time, right? We have seen the graphs. We have studied about the time. We have learned a lot in a very less time. Actually, in 1 hour we have learned everything. That is very important. What is switching, what is the concept of time, what is t equals to 0, what is t equals to 0 plus, what is t equals to 0 minus, right? We have seen the graph, what is steady state, what is transient, what do you actually mean by transient? Transient actually dies out, right? Only we are always left with a steady state value. Transient will die out. In final, we will have only the steady state. So that we have learned, right? So in the next video, we will learn about signals. Basic of signal is very much required. So we will study in the point of view of circuit analysis, okay? Not in the point of view of signals and systems. We will study it in the point of view of network analysis or the circuit analysis, okay? So in that point of view, we will study, okay? So we will see a very deep analysis of signals, okay? So even if you know the basics of signal, just do watch the video. First we will study about step signal, then impulse signal, then we will see the actual meaning of impulse signal. What do actually an impulse signal mean? Okay, then we will see ramp signal, then we will see differentiation or integration, then we will see how do we generate a step signal in circuit analysis, right? So all these things we will see. It will be a very interesting lecture. Next lecture will also be very interesting. So don't skip that lecture. Even if you know the basics of signal, do watch that lecture. Okay. So I hope you have understood the lecture. So we will be covering transient in very deep manner. Okay. I can guarantee you this will be the best ever lecture you have seen on transient. Okay. Just watch the complete series for transient and your concept will be crystal clear. Okay. Thank you.